This video is a continuation of section 2.1, and this video concerns finding ordered pairs that are solutions of equations. Now we're going to look at three different types of equations, all of which we've talked about already. We're going to look at linear, radical in the square root form, and then quadratic. Okay, and so what we want to find are three ordered pairs that are solutions to the equation. That means when I fill in a value for x and y, I get a true statement, that the left side of the equation has the same value as the right side of the equation. Now, in the past when we were solving equations, there was only one variable, and that's the only way you can solve the equation is if there is one variable. So if there's more than one variable, we have to do something, all right, to get it down to just one variable so we can solve for it. Now in all of these equations, there's an x and a y. And what we're going to do is we're going to pick a value for one of those variables. Now it doesn't matter which variable you pick for, and for the most part it doesn't matter what value you pick. On some equations there are some restrictions, and on some equations if you find one value, then you should find some others that relate to it, and that will just make it easier later on to graph it. Alright, but for the most part you can really just pick whatever you want. Okay, now the first equation, if you notice, is a linear equation. Now this equation is already solved for y. It says y equals negative 2x plus 5. So when I look at this equation, to me it is easiest to pick values for x and fill them in, and then simply multiply by negative 2 and add 5. If I do decide to pick values for y, I'm going to have to subtract 5 and divide by negative 2, and I run the risk of getting some fractions. So if I'll pick for x, then I'm sure to get some whole numbers. Alright, and that's important because later on we're going to be graphing these equations, and it's a little difficult to graph decimals or fractional parts on the graph. Much easier to graph whole numbers. Alright, so what I'm going to do is make me a table, and I'm going to make one column be x's and one column be y's, and then I'm going to make the last column be xy. So these are going to be my coordinates and the points that later on I'm going to plot. Okay, so we already decided that for this equation it would be easiest to pick values for x. Now you can pick whatever you want. This is linear. It has an infinite number of solutions. If you fill in for x, there are no restrictions to it. Alright, like some of the equations you're going to see here shortly. But I would stick to numbers that are small. Okay, so remember we're going to be graphing these in just a little bit, and you want to make sure that the coordinates that you pick will fit on the graph paper. Okay, there are an infinite number, but our paper is not infinitely big, so we have to limit the numbers to make sure they fit on our graphing paper. Okay, so I'm going to pick the values 0, 1, and 2. Now you can pick whatever you want: negative 1, 0, 1, 1, 2, 3, negative 2, negative 1, 0, negative 3, 0, 5. Okay, so there's no specific order. It doesn't have to go numerically. You can just pick random numbers. Alright, now that I've got my values for x picked, I'm going to go and substitute them in place of x and solve for y. So I'm going to do this one at a time. So over here on the right side, I'm going to say y equals negative 2 times, and the first I'm going to use 0. So in place of x, I'm going to put a 0. Then just work out the problem. Negative 2 times 0 is 0, plus 5 means that when x is a value of 0, y is a value of 5. So I'm going to come fill that into my table. That means the solution to this equation could be 0 for x, 5 for y. That would make a true statement. That would make the left side of the equation be a 5 and the right side of the equation have a value of 5. Alright, let's try 1 and see what we get. So we're going to take and fill in place of x. We're going to put a 1. So we'll have y equals negative 2 plus 5, which gives y a value of 3 when x is 1. So I'll come back to my table and fill it in. Alright, that gives me the point 1, 3. Lastly, I'm going to fill in a 2. So in place of x, I'm going to put the number 2. So we'll have negative 4 plus 5. All right, giving y a value of 1 when x is 2. So I'm going to put that in my table, like so. All right, let's move to the next equation. Now, all right, notice the next equation says y equals the square root of x minus 5. All right, now you really just kind of have to look at the equation and decide what is going to be the best way to get your numbers. With square root, remember, there are some conditions as to what can be under that square root sign, because I can't take the square root of a negative number. So when I fill in for x, I don't want to get a negative number. All right, and a way that you can avoid that is to pick values for y, and just make sure you pick numbers that are 0 or greater. Because when you take the square root, all right, whatever you get, that's going to be y's value. All right, and since the square root can't be negative, that means y can't be negative. So I'm going to pick values that are 0 or greater. Okay, so you have to look at the equation and where the variables were located, and just decide what is best to choose from. All right, or what variable is best to pick for. Remembering that square roots have some restrictions and they cannot be negative, so you have to pick your values accordingly. So to me, it's easiest in this case to pick values for y. So I'm going to make me a table. All right, and knowing that when I take the square root, it can't be negative, that tells me that y can't be negative. And the very smallest value that I could pick for y would be 0. So I'm going to pick the values 0, 1, and 2. All right, and you can pick anything you wanted to as long as it was 0 or greater. And then I'm going to take and fill these in for x and solve for y. So we'll say y equals the square root of 0. I did that wrong. Filled it in for the wrong one. Start that over. 0 equals the square root of x minus 5. All right, and so we're solving for x. All right, so we're going to square both sides. Remember that. From when we were solving radical equations, to remove the radical sign, we square it. Since we're squaring the right, we have to square the left. So that'll give me 0 equals x minus 5. I'm going to add 5 to both sides to find that one 0. Y is 0, x is 5. Then I'm going to come fill it in over here and get my coordinate. All right. Let's try 1. So I'm going to put 1 in y's place. And I'm going to solve for x. So I'm going to square both sides. 1 squared is 1. This leaves me x minus 5. I'm going to add 5 to both sides. And that tells me that when y is 1, x is a value of 6. Let's come over here to my table. Fill that in. All right. Make sure when you pick your values that you write them in the correct column for the variable you're filling them into. Otherwise, your points are going to be off. All right, lastly, we're going to fill in a 2 for y. So we'll say 2 equals the square root of x minus 5. I'm going to square both sides. And that will give me 4 equals x minus 5. I'm going to add 5 to both sides. All right, to find that x equals 9 whenever y is 2. So fill that in. All right, and get my point. All right, let's look at the third equation. All right, the third equation is quadratic. All right, and you can just randomly pick points for x and y still. All right, but with the quadratic equation, it has a graph that is a parabola. If you look down here at the bottom, a quadratic equation, its graph, and remember we said quadratic is the x squared tells us it's quadratic. Its graph is the shape of a parabola, and a parabola is symmetrical. All right, so what that means is down the middle of the parabola is an imaginary line called the axis of symmetry. And if I take and fold my parabola or my graph along that axis of symmetry, the left and right side should match up. Alright, and the point where that axis of symmetry crosses the parabola is known as the vertex. And so if you'll find the vertex first, and then pick points that are equal distance to the left and right of it, you'll get a good graph. If you're just randomly picking points, you may end up with points that are only on one side. Okay, and there is another way you could graph it by just randomly picking points, but then you're going to have to match it up. Which to me, the way we do it now will help you out in future sections when we do a little more complex quadratic equations that we're having to graph. Okay, so the way that I like to do it, all right, is to first find the vertex. And then I can pick points to the left and right of it. I'm going to get more points, but I'm not going to have any more work than I would if it were any other equation. Okay, so if I find the vertex, I'm going to look for the x coordinate of that vertex. All right, to find it, I take negative b and I divide it by 2a. So that should look familiar from the quadratic formula, right? All right, so remember that in quadratic equations, a is always the number in front of the x squared, b is the coefficient of the x term, and c is the constant. Okay, so if I look at my equation, all right, and I look at b, b is always the coefficient of the x. Well, there is no x in this equation. Therefore, there is no b, or b has a value of 0. Okay, and so for most of the problems that are going to be in your homework and on this test, b is going to be 0. There's not going to be a b. There's not going to be an x term. So it's simply going to be the x squared plus or minus a number. So your basic parent function of quadratics, x squared, with the value added or subtracted from it. There's going to be no b, no x. All right, so in our case, b is 0. Then we're going to take 2 and multiply it times 1. That'll be 0 divided by 2 is 0. All right, I'm going to come over here and make me a table. Same thing with the x and y values. All right, and in my table, I'm going to put my vertex value right in the middle. All right, and from the vertex, I'm going to pick values that are the same distance to the left and right of that vertex. And I want to pick 2 values to the left and 2 values to the right. Okay, so if you think about 0, if I'm moving to the right 1 spot, that would put me at 1. And then if I move 1 place to the left of the vertex, that would put me at -1. If I move 2 places to the right of the vertex, that would put me at 2. And if I move 2 places to the left of the vertex, that would put me at -2. All right. Now what's good about doing this is because the parabola is symmetrical, these 2 values right here are going to have the same y value, so you only need to insert one of them. It doesn't matter which one. Once you fill in one and get your y, you can automatically insert that value for y into the other x coordinate. The same thing goes for -2 and 2. Because they're the same distance from the vertex, they will have the same y value. Okay, so let's find what those are. So I'm going to come over here and fill in. I'm going to do -2, but you could do 2 if you wanted to. Alright, so when I fill in -2 into my equation, -2 squared is 4, plus 1 gives me a y value of 5. Alright, so -2, 5 is my coordinate. And since 2 has a y value of 5, 2 has a y value of 5, because -2 and 2 are the same distance from 0, the vertex. Alright, next I'm going to fill in 1. So I'm going to fill in 1 in x's place. And I'll get 1 plus 1, which is 2. Alright, so that tells me the y value for x is 1. That means the y value for -1 is also 2. Lastly, I'm going to fill in 0. That'll give me 0 plus 1, which is 1.